Explain the atomic origin of magnetism. We know that certain materials behave like a magnet without any influence of external magnetic field. And certain materials behave like a magnet only when an external magnetic field is applied on them. So why is it that some materials behave as a permanent magnet, and some materials show the property of magnetism only when an external magnetic field is applied on them? To understand this, let's analyze the material at an atomic scale. We know that an atom consists of nucleus, surrounded by electrons that revolve around it. And the electrons and nucleus also rotate about their own axis. We also know that the flow of charge indicates the flow of current. And when a current flows through a circular coil, magnetic moment gets induced in the coil in the direction given by the right-hand thumb rule. Similarly, in an atom, the rotation of nucleus and the revolution and rotation of electrons indicates the flow of small currents in them. This flow of current induces magnetic moments. The resultant of all the magnetic moments gives the net magnetic moment of the atom. Now, if all the magnetic moments induced in the material are in the same direction, then the material behaves like a magnet without any application of external magnetic field. But if all the magnetic moments induced in the material are in different directions, then they cancel out each other and their resultant becomes zero. In such cases, the material does not behave like a magnet. To make such materials behave like a magnet, we need to apply some external magnetic field on them. Thus, we can say that atomic origin of magnetism in any magnetic material can be explained by taking into consideration the magnetic moments of the spinning and revolving electrons and also that of the spinning nucleus. Mathematically, magnetic moment due to the revolving electrons is given by magnetic moment due to the spinning electrons is given by, and the magnetic moment due to the spinning nucleus is given by, where the related term is